Hi dears, we are going to discuss a new topic, acceleration due to gravity. You all are familiar with the word acceleration due to gravity. When we drop an object from a height h, what happens? It falls down due to the gravitational force exerted by the earth. So, what do you mean by acceleration due to gravity? So, due to that gravitational force, that object attained an acceleration. So, the acceleration gained by the object due to the gravitational force, that is called the acceleration due to gravity. Or we can say that it is the acceleration of a freely falling object. Acceleration of a freely falling object. So, acceleration due to gravity is the acceleration gained by an object due to gravitational force, or it is the acceleration of a freely falling object. Okay, so let us obtain an expression for acceleration due to gravity. How we obtain an expression for acceleration due to gravity? Consider Earth as a perfect sphere having radius r. So, we are considering Earth as a perfect sphere of radius r. So, the radius of the Earth can be taken as r and the mass of the Earth can be taken as m. Mass of the Earth can be taken as m. Then, we are placing an object of mass m on the surface of the Earth. Place an object of mass m on the surface of the Earth. So, according to law of gravitation, Earth attracts this object towards its center. So, the radius of the Earth can be taken as r. So, according to Newton's law of gravitation, the gravitational force between Earth and this object is given by F is equal to G m. M is the mass of Earth and small letter m is the mass of the object divided by the distance between these two objects. So, that is the radius of the Earth. So, we can write it as F is equal to G m by r square. So, the gravitational force between the Earth and this object is given by F is equal to G m by r square. So, we know that when an object is dropped, an acceleration acts on the body according to Newton's second law of motion. By Newton's second law, we have F is equal to ma. Here the acceleration due to gravity is can be taken as g. So, instead of a we can give g. So, what is the force? Force is given by F is equal to mg. Okay. So, according to law of gravitation, the force is given by g mm by r square, and by Newton's second law, force is given by F is equal to mg. So, this can be taken as equation number 1 and this can be taken as equation number 2. Okay. Then, compare these two equations. Compare equation 1 and 2. So, we can write mg is equal to g m divided by r square. So, mg is equal to g mm divided by r square. So, we can cancel this m and m. Then the acceleration due to gravity is given by g is equal to gm divided by r square. Okay, we know that capital G is the gravitational constant, m is the mass of Earth and r is the radius of Earth. Okay, then you are familiar with the value of acceleration due to gravity. You have studied that in lower classes, you have studied that it is 9.8 meter per second square. So how we get that value? So here we can calculate acceleration due to gravity on the surface of the earth. So we are calculating acceleration due to gravity. Acceleration due to gravity on the surface of the earth. On the surface of the earth. Surface of earth. So which is the equation? The equation to calculate acceleration due to gravity is G is equal to Gm divided by R square. Okay, so substitute all the values. G is equal to, the value of G is capital G, gravitational constant, is given by 6.67 into 10 raised to minus 11. And m is the mass of earth or mass of the planet. So mass of the earth is given by 6 into 10 raised to 24 kilogram. Mass of earth is given by 6 into 10 raised to 24 kilogram. And the radius of earth is given by 6.4 into 10 raised to 6 meter. 6.4 into 10 raised to 6 meter. Okay. So that means 6,400 kilometer. So we can write like this, 6.4 into 10 raised to 6 meter. If we calculate this value, we will get the value of G is almost equal to, there may be small variations, 9.8 meter per second square. From lower class, you have studied the value of acceleration due to gravity is 9.8 meter per second square. So we can obtain the value of acceleration due to gravity by this method. So equation to calculate acceleration due to gravity is G is equal to Gm divided by R square. We are applying all the values. We will get the G is equal to 9.8 meter per second square. Okay. Next, I just drop two objects. One is having mass 5 kilogram and another having mass 10 kilogram. My question, which object or which body reach the ground first? One is of 10 kilogram and one is of 5 kilogram. So the answer is both of them reach the ground simultaneously. So you have a doubt, it depends on mass. G is equal to Gm by R square. But listen, this m is not the mass of the object. This m is the mass of the earth or mass of the planet. So the acceleration due to gravity is independent of the mass of earth. Okay, the acceleration, keep in your mind, the acceleration due to gravity is independent of mass of earth. Okay, so the both objects reach the ground simultaneously because both having the same acceleration. Okay, then so we can say that the acceleration due to gravity is independent of the mass of earth. So the equation to calculate acceleration due to gravity in terms of mass is given by G is equal to Gm divided by R square. Okay. Then, so we have an equation to calculate acceleration due to gravity, that is G is equal to Gm divided by R square. So that is in terms of mass. So you have to obtain an equation for acceleration due to gravity in terms of density. Okay, so density of earth, in terms of density of earth. Here we consider earth as a perfect sphere having uniform density. Okay, so we are calculating the acceleration due to gravity in terms of density. So we know that, which is the equation to find density? Density rho is equal to mass divided by volume. The density is given by, we have an equation, mass density is given by rho is equal to mass by volume. Okay, so we have already one equation, G is equal to Gm divided by R square. G is equal to Gm divided by R square. From this, what is m? M is equal to G R square divided by m. Sorry, G R square divided by g. Gr square divided by g. M is given by gr square divided by g. So we got the value of m. So we are considering Earth as a perfect sphere. Actually, it is not a perfect sphere, but here we are considering Earth as a perfect sphere having uniform density. Then listen, we can write the volume of the Earth is given by, because it is a perfect sphere, the volume of a sphere can be taken as 4 by 3 pi r cube. So the volume is given by V is equal to 4 by 3 pi r cube. Then apply these two equations. One is mass is equal to gr square by g and V is equal to 4 by 3 pi r cube into this equation. That is, rho is equal to, we can write mass is given by gr square divided by capital G divided by 4 pi r cube by 3. So take reciprocal and multiply, that we can write 3 divided by 4 pi r cube. So what is that? Take, this is here, it is mass by volume, then volume is equal to 4 by 3 pi r cube, then take reciprocal and multiply, that is 3 by 4 pi r cube. So we can cancel this r square. Okay, so r remains here, is r cube, so r remains there. So we can write rho is equal to 3g divided by 4 pi gr. So density is equal to 3g divided by 4 pi gr. So here we have to obtain an expression to calculate acceleration due to gravity in terms of density. So how will be it? G is equal to 4 pi g r into rho, 4 pi g r into rho divided by 3, or we can write like this, it is 4 by 3 pi g r rho. The value of acceleration due to gravity in terms of density is given by g is equal to 4 by 3 pi g r rho. So we have obtained an equation to calculate acceleration due to gravity in terms of mass, and also we have obtained an equation to calculate acceleration due to gravity in terms of density. Okay, next, my question. We are discussing variation of acceleration due to gravity. So we have a value on the surface of the earth for acceleration due to gravity is 9.8 meter per second square. So first of all, is there any variation in the value of acceleration due to gravity due to these four? Which is the first one, shape of earth. Is there any variation in the, is there any change in the value of acceleration due to gravity due to the shape of earth? After that, when we go, suppose an object is taken to a height h from the surface of the earth, is there any change in the value of acceleration due to gravity? And next, depth. When we go down, an object is taken to a depth, is there any change in the value of acceleration due to gravity? And fourth one, is there any change in the value of acceleration due to gravity due to the rotation of the earth? We know that earth rotates in its own axis. So that due to the rotation of the earth, is there any change in the value of acceleration due to gravity? So we have to discuss all these four cases. Okay. So first of all, let us discuss the variation of g due to shape of earth. Okay. Is there any change in the value of acceleration due to gravity due to the shape of the earth? So we have already one equation, which is the equation g is equal to gm divided by r square. So the acceleration due to gravity is equal to gm divided by r square. Okay, so from this we can write g is proportional to 1 by r square. That means when the value of r increases, the value of acceleration due to gravity decreases. So we know that earth is not a perfect sphere. So the equatorial region is bulged. That means the equatorial radius is greater than that of the polar radius. So this is the equatorial radius. So this is the equatorial radius. So we can take it as RE, equatorial radius. And also this is the pole and this is the distance to the pole that can be taken as polar radius. So we know that this equatorial radius is greater than that of polar radius. Equatorial radius is greater than that of polar radius. Listen, here this is the distance from the center of the earth to the equator, and here is the distance from the center to the pole of the earth. So here we can find that the distance to the equatorial region of the earth is greater than that of the distance to the pole of the earth. That means equatorial radius is greater than that of polar radius. So listen, we have already mentioned that when the radius increases, when the distance increases, what happens to acceleration due to gravity? Acceleration due to gravity decreases. So the radius of equatorial radius is more than that of polar radius, so that acceleration due to gravity at pole is greater than that of acceleration due to gravity at equator. So on the surface of the earth, when we move from equator to pole, what happens to the value of acceleration due to gravity? Acceleration due to gravity increases, because the value of acceleration due to gravity is minimum at equator and maximum at pole. We can say that the value of acceleration due to gravity is a minimum at equator. Minimum at equator. Okay, and it is maximum at pole. The value of acceleration due to gravity is maximum at pole. Okay, so minimum at equator and maximum at pole. So we have already studied the equation to calculate weight. So which is the equation to calculate weight? Weight is equal to mg. Okay, so the mass is a constant. When an object is moving from equator to pole, the mass remains constant, but the value of acceleration due to gravity increases. It means that weight of an object increases when we move from equator to pole, because the value of acceleration due to gravity increases when we move from equator to pole. Okay, so keep in your mind, the weight of an object increases from equator to pole. So we have already discussed about the variation of acceleration due to gravity due to the shape of the earth. Next, we are discussing variation of acceleration due to gravity with altitude. Suppose an object is taken to a height h. What happens to the value of acceleration due to gravity at a height h? Okay, let us discuss that. Consider, we have already mentioned that the mass of the earth can be taken as m, capital M. Okay, and the radius of the earth can be taken as r. So this is earth radius, this can be taken as r. So we have already discussed about the value of acceleration due to gravity on the surface of the earth. So I take this object to a height h from the surface of the earth. So an object is here, the height from the surface of the object is given by h, can be taken as h. So the mass of this object can be taken as m. So you have to find the acceleration due to gravity at a height h. First of all, to obtain the equation, we know that value of acceleration due to gravity on the surface of earth, that is given by g is equal to gm divided by r square. The value on the surface of earth can be taken as g is equal to gm divided by r square. Next, we are taking the object to a height h. Then what will be the acceleration due to gravity at a height h? So at a height h, at a height h, at a height h. So what is the total distance from the center of the earth? That is r plus h. So the acceleration due to gravity at a height h can be taken as gh. That gh is equal to, there is no change in the value of gravitational constant and there is no change in the mass of earth, divided by, but the distance is r plus h. It is not r, it is r plus h. So we can take it as r plus h all square. So the value of acceleration due to gravity at a height h is given by gh is equal to gm divided by r plus h all square. So this can be taken as equation number 1 and this can be taken as equation number 2. Okay, the next step, you have to find the value of acceleration due to gravity in terms of this g. G means acceleration due to gravity on the surface of the earth. So just divide equation 2 with 1. So how we find the value? So we are finding equation 2 divided by 1. So we can write gh divided by g is equal to, so what is gh? That is gm divided by r plus h all square. Gm divided by r plus h all square, all divided by gm by r square. So you can take reciprocal and multiply. So let us take its reciprocal and let us multiply it. That is r square divided by gm. Take reciprocal and multiply. So in the next step, we can cancel this gm and gm. So what is gh by g? Gh by g can be written as gh by g is equal to r square divided by r plus h all square. So what is that? Gh by g is equal to r square divided by r plus h all square. Okay. So just expand this r plus h all square. That is gh by g is equal to r square divided by what is a plus b all square? That is r square plus a square plus 2ab, that is 2rh plus b square. Here it is b, so we can take it as h square. Okay, so that is r square divided by r square plus 2rh plus h square. So what is gh by g? That is gh by g is equal to, we can write like this, r square divided by r square plus, multiply this 2rh with r and divide it with r. So how will be the equation? Multiply this 2rh with r, it will become 2r square h divided by r. So there will not be any change in the value because r square can be cancelled, then it will become 2rh. Then plus, what is h square? Multiply h square with r square divided by r square. There will not be any change in the value because the denominator and numerator is multiplied with the same value. So h square r square divided by r square. Okay, then what is the next step? So gh by g is equal to r square divided by, take r square outside. So how will be the equation? R square into 1 plus, when we take r square, you will get it as 2h by r plus, what is, when we take this r square outside, you will get h square by r square. So that is gh by g is equal to r square divided by r square into 1 plus 2h by r plus h square by r square. Okay. Then what is this 1 plus 2h by r plus h square by r square? So just listen. What is 1 plus h by r all square? What is 1 plus h by r whole square? That is equal to, expand it, a square, that is 1 square, plus 2rh, 2 into 1 into 2ab, that is 2 into 1 into h by r. So we can write 2h by r, plus b square, b is h by r, so b square means h square divided by r square. So 1 plus h by r whole square can be written as 1 plus 2h by r plus h square by r square. So what is that 1 plus 2h by r plus h square by r square? That is given by gh by g is equal to r square. So we can, before that we can cancel this r square. So this r square can be cancelled, r square by r square, by 1 by, what is 1 plus 2h by r plus h square by r square? That's equal to 1 plus h by r whole square. So we can write 1 plus h by r whole square. Okay, so what is the value of acceleration due to gravity? The value of acceleration due to gravity at a height h is given by gh is equal to g divided by, can be taken to this side, by 1 plus h by r whole square. So what is that? The acceleration due to gravity at a height h is given by gh is equal to g by 1 plus h by r whole square, where gh is the acceleration due to gravity at a height h, g is the acceleration due to gravity on the surface of the earth, and h is the height from the surface of the earth, okay, and r is the radius of the earth. So from this equation we can find that when height increases, what happens to the value of acceleration due to gravity? When height increases, this is 1 plus h by r. That means when the value of h increases, the value of denominator increases. That means the value of acceleration due to gravity decreases as we move from surface of the earth to a height. Okay, so we can say that value of acceleration due to gravity, value of g decreases as we move from surface to a height h. When the height increases, the value of acceleration due to gravity decreases. The value of acceleration due to gravity decreases. So you can use this equation to find the value of acceleration due to gravity. And also, if the value of h is very less than r, if the value of h, height, is very less than that of r, we know that the radius of the earth is 6,400 kilometer. If the value of h is 100 kilometer or 50 kilometer, 50 kilometer, so we can use another equation. That means h is very less than, is 100 kilometer. H is very less than r. So we can use this equation to calculate the value of acceleration due to gravity. That is given by gh is equal to g into 1 minus 2h by r. So what is that? Gh is equal to g into 1 minus 2h by r. This equation can be used only for the height h, which is very less than that of radius of the earth, which is very less than that of the radius of the earth. Then we have understood that from this equation we have understood that when we go up, what happens to the value of acceleration due to gravity? So when the height increases, the value of acceleration due to gravity decreases. The value of acceleration due to gravity decreases as we move from the surface of the earth to the height. Okay, so we have already discussed the variation of acceleration due to gravity due to the shape of the earth, and there is a change in the value of acceleration due to gravity. When we go up, the value decreases. Okay, so next, before that, so let us do one question based on this. We know that as we go up, the value of acceleration due to gravity decreases. Then what happens to the weight of the object? Weight of the object also decreases, because when we move from the surface to a height h, the mass of the object does not change. So the value of acceleration due to gravity decreases, then the weight also decreases. A body weighs 63 Newton on the surface of the earth. What is the gravitational force? Gravitational force means is the weight, okay, on it due to the earth at a height equal to the radius of the earth. That means we know that when we go up, the value of acceleration due to gravity decreases. Then what happens is weight, its weight also decreases, because W is the weight is equal to mg, mass into acceleration due to gravity. When the value of acceleration due to gravity decreases, what happens to weight? Weight also decreases. So in the question, it is given that a body weighs 63 Newton on the surface of the earth. So it is given by weight on the surface of the earth can be taken as weight is equal to 63 Newton. It is already given, or we can write the weight on the surface of the earth is given by mg, and that is equal to 63 Newton. The weight on the surface of the earth is given by 63 Newton. What is the gravitational force? That means weight on it due to the earth at a height equal to the radius of the earth. So in the question it is given that at a height which is equal to radius of the earth. Okay, so it is clearly mentioned that the height is given by r. So that height is equal to the radius of the earth. So we have an equation to calculate acceleration due to gravity at a height h. So which is that equation? That is gh is equal to g divided by 1 plus h by r all square. So what is that? Gh is equal to g divided by 1 plus h by r all square. So how we calculate the weight? Weight is equal to, that means weight at a height h is equal to mgh. So weight on the surface of the earth is given by mg. Then weight at a height h is equal to m into gh, mass into acceleration due to gravity at a height h. So first of all, we can calculate the value of acceleration due to gravity. So what is that? Is equal to, okay, is equal to g divided by, what is 1 plus h by r all square? That is 1 plus, we know that it's already given in the question, h is equal to r. So we can take r by r, that is r by r all square, r by r all square. Okay, so that is, what is r by r? It is equal to 1. So we can write 1 plus 1 2 square. So value of gh is equal to g divided by 2 square. So the value of acceleration due to gravity decreases by 4 times. So you have to calculate the weight. How will you calculate the weight? Weight is equal to mgh. So weight at a height is given by mgh. So gh is already given, that is g by 4. So we can write that is equal to g, instead of gs can be given g by 4. So weight at a height is given by mg by 4. So what is the value of mg? That means on the surface of the earth it is equal to 63 Newton. So what is the weight at a height h? Weight at a height h is given by 63 divided by 4. So what is the value of 63 divided by 4? So the value of acceleration due to gravity decreases when we go up. So that is given by, so that's almost equal to 57.75. It is equal to 57.75. Okay, so that much of Newton. So weight at a height h is given by 57.75 Newton. So the weight decreases by 4 times. Weight decreases by 4 times. Okay, let us do one more question, which is based on the value of acceleration due to gravity at a height h. The question is, find the height at which the acceleration due to gravity is reduced to half. So we know that when we go up, the value of acceleration due to gravity decreases. So the question is, when we go up, the value of acceleration due to gravity decreases and reaches at a value which is half of the value of acceleration due to gravity on the surface of the earth. So at a height h, we have an equation to calculate acceleration due to gravity, that is gh is equal to g divided by 1 plus h by r all square. So gh is equal to g divided by 1 plus h by r all square. So it is given in the question, you have to find the height at which the value of acceleration due to gravity become half. That means the value of gh become half of the value of acceleration due to gravity on the surface of the earth. That is given by gh. That is gh is equal to g by 2 is equal to g divided by 1 plus h by r all square. 1 plus h by r all square. Okay. So we can cancel this g and g. We can cancel this g and g. That is 1 by 2 is equal to 1 plus h by r all square, or we can write 1 plus h by r all square is equal to 2. What is that? 1 plus h by r all square is equal to 2. Okay. So here it is square. To the right side it will become a root 2. So we can write 1 plus h by r all square is equal to root 2. Okay. Then next, what is h by r? What is h by r? So you have to find the value of h. H by r is equal to root 2 minus 1. Okay, root 2 minus 1. That is, height can be calculated using this equation, root 2 minus 1 into r. So we know the value of radius of the earth. The value of radius of earth is given by 6.4 into 10 raised to 6 meter. Okay, then what will be the value of h? So that is h is equal to, so the value of root 2 is given by 1.414. So we can calculate 1.414 minus 1, that is 0.414. That is into, what is the radius of the earth? That is 6.4 into 10 raised to 6. Okay, so that is 0.41 into 6.4. So what is the value? That is 64 into 41 is equal to 4, then 6, 16, then 25. So that is equal to 4, 2, 6, 2. So the value is equal to 1, 2, 3. 3 points are there, that is 2.62. What is that? 2.62. So that is h is equal to 2.62 into 10 raised to 6 meter. Okay, the height is given by 2.62 into 10 raised to 6 meter. So at a height 2.62 into 10 raised to 6 meter, the value of acceleration due to gravity become half. Okay, so we have already discussed about the variation of acceleration due to gravity due to the shape of earth, and also the value of acceleration due to gravity at a height h. Next, what happens to the value of acceleration due to gravity when we go down? If we take an object to a depth d, what happens to the value of acceleration due to gravity? So let us discuss it. Okay. So here, listen, this is the center of the earth and this is the radius of the earth. When we go down, this is the surface of the earth. When we move to a depth d, so this is the depth d. When we move to a depth d, what happens to the value of acceleration due to gravity? Is it increase or decrease? So let us find out. So this distance can be taken as, the distance from the center to this point can be taken as r minus d. So what is that? R minus d. So value of the acceleration due to gravity on the surface of earth. So on the surface of earth, what is the value of acceleration due to gravity? So we know that in terms of density, the value is given by g is equal to 4 by 3 pi g r rho. So we have already discussed about it. The value of acceleration due to gravity in terms of density is given by g is equal to 4 by 3 pi g r rho. So on the surface of the earth, the value is radius r. So r into rho. Next, at a depth d, what is the value of acceleration due to gravity? The value of acceleration due to gravity at a depth d is given by, there is no change in the value of these constants, that is 4 by 3 pi g. G is the gravitational constant, there is no change when we go down. Then what happens to this distance? Distance from the center to that point can be taken as r minus d. So at a depth d, this r become r minus d. Okay, into, we considered that the earth is a sphere of uniform density. So rho is also constant, it is uniform. So g is equal to 4 by 3 pi g r rho and gd is equal to 4 by 3 pi g r minus d into rho. Okay, so this can be taken as equation number 1. This can be taken as equation number 2. Then what is next? So you have to find the acceleration due to gravity at a depth d in terms of acceleration due to gravity on the surface of earth. So what is equation 2 by 1? So equation 2 by 1 can be taken as gd by g is equal to 4 by 3 pi g r minus d into rho divided by, what is g? Gd by g is equal to 4 by 3 pi g r into rho. So this 4 by 3 pi g and 4 by 3 pi g can be cancelled. Rho and rho can be cancelled. What is the value of gd by g? The value of gd by g is equal to, the value of gd by g is equal to r minus d divided by r. So the value of gd by g is equal to r minus d divided by r. Okay, then this can be written as gd by g is equal to, r minus d by r can be taken as r by r is 1 minus d by r, so that is 1 minus d by r. Okay, then what is the value of gd? Gd is equal to g into, this come to this side, then into 1 minus d by r. So the value of acceleration due to gravity at a height h is given by, the value of acceleration due to gravity at a height h is given by gd is equal to g into 1 minus d by r. So from this equation, we can understand that when we go down, what happens to the value of acceleration due to gravity? That is g minus gdr. That means the value of acceleration due to gravity decreases. When we go down, when we go to a depth d, the value of acceleration due to gravity decreases. When we go up, the value of acceleration due to gravity decreases. So the value of acceleration due to gravity is maximum on the surface of the earth. On the surface of the earth, the value of acceleration due to gravity is maximum at a pole and minimum at a equator. When we go up, the value of acceleration due to gravity decreases, and we go down, the value of acceleration due to gravity decreases. Okay, so the maximum value of acceleration due to gravity is on the surface of the earth. Then from here, gd is equal to g into 1 minus d by r. My next question, at the center of earth, at the center of the earth, what is the value of acceleration due to gravity? So consider this is earth. Okay, so when at the center of the earth, the radius is equal to what? Depth. Depth is equal to radius. At the center of the earth, the depth is equal to radius. At center, so we can write at center, what is d? D is equal to r. So gd can be taken as the acceleration due to gravity at a depth d can be taken as g into 1 minus, what is d? D is r, that is r by r. R by r is equal to 1, 1 minus 1, it is equal to 0, g into 0, the value of acceleration due to gravity at the center of the earth is equal to 0. Keep in your mind, the value of acceleration due to gravity at the center of the earth is equal to 0. Okay. So we have already discussed about the value of acceleration due to gravity due to the shape of the earth at a height h and at a depth d. Next, let us do some questions from this. The acceleration due to gravity at a depth d below the surface of earth is 20% of its value at the surface. So we can take at the surface the value of acceleration due to gravity can be taken as g. So here the value of acceleration to gravity at a depth d is 20% of its value at the surface. That can be written as the gd, the acceleration due to gravity at a depth d is equal to 20% means that is 20 by 100 into value of acceleration due to gravity on the surface of the earth. So the value of acceleration due to gravity gd is equal to 20 divided by 100 into g, that means 20% of g. So you have to find the what is the value of d if the radius of the earth is 6,400 kilometers. So you have to find the value of acceleration due to, you have to find the value of d. So which is the equation to find acceleration due to gravity at a depth d? That is equal to g into 1 minus d by r. So what is that? G is into 1 minus d by r. Okay. Then what is the value of gd? Gd is equal to at a depth d 20% of g, that is 20 by 100 into g. So we can write 20 by 100 into g is equal to g into 1 minus d by r. So g can be cancelled, 0 can be cancelled, that is 2 by 10 is equal to 1 minus d by r. So minus d by r can be taken to this side, then we will get d by r is equal to, what is that? D by r is equal to 1 minus 2 divided by 10. D by r is equal to 1 minus 2 by 10. What is 1 minus 2 by 10? That is 8 by 10. So we can write d by r is equal to 8 by 10. What is d? What is the value of d? D is equal to 8 by 10 into 6,400. So what is the value of 8 by 10 into 6,400? That is equal to, d is equal to 5120 kilometers. So because the value of radius is given in kilometer, so the answer is 5120 kilometer. Okay, so at a depth 5120 kilometer, the value of acceleration due to gravity become 20% of the value of acceleration due to gravity on the surface of the earth. Okay, so let us move to another question. At what height above the surface of the earth value of g is same as in a 100 kilometer deep? So the question is, you have to find the height at which the value of value of g is same as in a 100 kilometer deep. So let us compare the value of acceleration due to gravity at a height h and at a depth d. So it is equal. You have to make it into equal because you have to find that value. Okay, for that here it is 100 kilometer deep. It is very less than r. The value of height h is very less than r. So we can write which equation we can use? We can write here GD is equal to GH. GD is equal to G into 1 minus D by R. This is equal to GH. So we can take the value G into 1 minus 2H by R. Why? It is only 100 kilometer. The value of H is very less than R. If the value of H is very less than R, we can use the equation G into 1 minus 2H divided by R. So next, from this, by comparing this, we can find that what is the value of D? D is equal to 2H. So what is D? D is equal to 2H. What is the value of H? H is equal to D by 2. What is the value of H? H is equal to D by 2. So what is D? D is equal to 100 kilometer. So we can write H is equal to D by 2. That is 100 divided by 2 is equal to 100 divided by 2 is equal to 50 kilometer. So at a height 50 kilometer, the value of acceleration due to gravity is same as at a depth 100 kilometer. Okay, so the answer is h is equal to height is equal to 50 kilometer. Okay. So we have already discussed about the variation of acceleration due to gravity to the shape of the earth at a height h and at a depth d. What is next? Next we are discussing the variation of acceleration due to gravity due to rotation of earth. So due to rotation of earth, what happens to the value of acceleration due to gravity? So the value of acceleration due to gravity due to the rotation of the earth is given by G dash is equal to G minus R omega, keep this equation in your mind, R omega cos square theta. So this is the equation to find the value of acceleration due to gravity due to the rotation of earth. What is theta? Theta is the latitude. What is theta? Theta is the latitude. Okay, then we know that this is the latitude, this is the latitude. It makes from this value, this is the latitude. Okay, then at equator, what is the value of latitude? At equator, from the figure we can understand that at the equator, the value of latitude is equal to 0 degree. Okay, so what is the value of theta? Theta is equal to 0 degree. So what is G dash? G dash is equal to G minus cos square theta, cos square 0, it will become 1. Then we can write like this, G minus R omega square. So G dash is equal to G minus R omega square. So at equator, the value of acceleration due to gravity is given by G minus R omega square. So here omega is the angular velocity of rotation of earth. So G dash is equal to G minus R omega square cos square theta. So at equator, theta, the value of latitude is equal to 0 degree. Then we can write G dash is equal to G minus R omega square. Then at pole, what is the value of latitude? At pole, the value of latitude is equal to 90 degree. Then we can write theta is equal to 90. So what is the value of cos 90? Cos 90 is equal to 0. Cos square 90 is equal to 0. Then what is the value of G dash? G dash is equal to G. At pole, G dash is equal to G. So due to the rotation of earth, the value varies. At equator, it is given by G dash is equal to G minus R omega square, and at the pole, it is given by G dash is equal to G. Okay, so in this topic, acceleration due to gravity, we have discussed what we mean by acceleration, and also the value of how the expression to calculate the value of acceleration due to gravity in terms of mass and also in terms of density. Then we have discussed the variation of acceleration due to gravity. due to the shape of Earth. Then at a height h, then at a depth d. At last we have discussed the variation of g due to rotation of Earth. So let us wind up this session here. Thank you.